Transformation. Remember the little toy, the Transformer toys? And it's like, you know, the little robot, you do stuff and it turns into, I don't know, what does it turn into? Like a flying thing? Alien thing? Yeah, so it transforms. So we're going to be transforming things. Alien things. Okay. Transformation. So let's just review what you already know. You know a lot about these already. Transformation moves or changes a geometric image in some way. Transformation. A pre-image. You may or may not have used that word when you learned about transformation. That's the thing you're starting with. And the image is the thing you wind up with. So if you're starting with your little transformer in little human or creature form, the image might be when it becomes the flying spaceship weird thing. So here's a pre-image, here's its image. What you start with, obviously pre, and then it's transformed image. We use some notation here. The pre-image points are like A might be a point, and then we call it A prime. That's our image point. So you might change the original point to something else based on your transformation, A to A prime. What else do we know? Translation. These are kinds of transformations. You may have had somebody who pointed out the SL in translation. Remember that slide? So you're moving every point the same distance in the same direction. Translation. It's like you're sliding a figure on different places on the plane. A reflection. That one has an FL. You know what this is? It's a flip. You're flipping things around. Maybe you're flipping it this way. Maybe you're flipping it up and down. That's a reflection. Rotation has a T. It's a turn. So you're kind of just turning it around and around. And then a dilation, I got nothing for you here, but a dilation is when it's proportionally bigger or proportionally smaller. You create similar figures to the one you're starting with. These sound familiar? Anybody? Raise your hand if you've heard these words. Okay. We're going to look at, which figure is a translation of A? So here's my original. Which one is the slide? Which one is the translation? Which one, Rachel? B. It's like I took it and I just slid it right over. Everything else looks the same, right? It's just in a different position. Which one is a reflection, the flip? Which is a flip? Which one? With D. You took this and you kind of flipped it that way, you get this. It's a reflection, mirror image. Which is a rotation? Turn this thing around, Andrew. You see. Turning it around, it looks like we want, we got it upside down. So, that's it. Translation, reflection, rotation. Let's see if we can identify these guys. What's that? Translation, reflection, rotation, dilation. What is it? Reflection. It's a flip. It's a flip. And we're rotating over a line. We're rotating over line H. Reflection, rather. This guy is what? What's happening here? What is that? Oh, I guess you could say translation, but what am I really doing here? What is this? Looks like a rotation. But I can see it, well, you might say, I guess a translation is kind of like a rotation. But we're rotating around a point. What's going on here? The slide, what's the big boy word? Translation. Yep. Translation. And then what's happening here? The dilation. You're getting a proportionally similar figure. Dilation. All right, so let's focus more on the translation. It moves pre-image points the same horizontal and vertical unit. So we're moving in units. I'm not sure I'm pronouncing this word right. It's either isometry or isometry. I don't know what it is, but I'm going to go with isometry. It translates or isometries. You're getting a congruent figure when you're done. They match. They're just in a different spot. There are rules that describe the translation. How many horizontal, how many vertical changes do you make? So to do ones like this, and this one's on your paper here, so you can do this one with me. We're going to put this quadrilateral ABCD on the coordinate plane. Right, so let's go do that. Wrap them in there. A is -1 and 2. There's A. Label your points after you put them on. B is -1, 5. Okay, then we're going to put C on this plane. Everybody doing it? I see a few people write it down. Everybody should be putting this in their notes. Okay, C is 4, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5. And D is 4, 2. 1, 2, 3, 4, 5. And it's quadrilateral, so we're going to take a quadrilateral. Okay. Now it says find the image of each vertex after the translation. Now here is how our notation. We say xy, each point becomes x plus 3, y minus 1. So what do I do to x plus? What do I do to each x? Add 3, and what do I do to each y? Subtract 1. Now when you took this before, you probably did something like this. It said, great. So you start at x and you count 1, 2, 3, right? And then you go down 1? Yes? Is that what they told you? They told you something. How'd you do this back in 6th grade? I can't remember how you do this. 1, 2, 3, 1. Right? You can just count them. See, we're just going to count them. Let's see what I do. 1, 2, 3, down 1. And then 1, 2, 3, down 1. And now I've got my translation. Now what we're going to start doing here is we're going to be a little more rule-oriented. So what you do is you write your original points down. So A is negative 1, 2. B is negative 1, 5. C is 4, 6. And D is 4, 2. We're going to actually do the translation based on how this works. So what does A prime become? What does A prime, B prime, so what are the values of A prime? Add 3 to negative 1, what do you get? 2. And subtract 1 from 2, you get 1. Is that what we got here? 1, 2, 1. Yes. All right, B prime, same thing. Add 3 to the x, negative 1 plus 3 is still 2. And then 5 minus 1 is 4. Isn't that what we got here? 1, 2, 1, 2, 4. C prime, add 3 to x, subtract 1. 7, 5, is that what we got? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And then D prime becomes 4 plus 3 and 2 minus 1. 1, 2, 3, 4, 5, 6, 7, 1. So we're actually making the mapping to those points. So rather than just, I'm just going to count over, we're creating those primes, the different points that we get here. So that's what we should have gotten. Okay, translations. Okay, it's not rocket science, but just kind of getting used to this kind of notation. Okay, another way to think about these things, vectors. I get to be the person to introduce vectors to you, though I mean that. Did anybody see that movie a few years ago, this guy? Is that guy? Vector. I have to say, when I saw this movie, I was like, you got a movie with a character named Vector? Here he is if you don't know him. You saw this too? You doing vectors there? I don't know how to make this bigger.
It's a mathematics. Quantity represented by an arrow with both direction and magnitude.
All right, let's wait. I gotta hear that again. Wait.
Vector. I'm applying. You go by the name of Vector. It's a mathematics. Quantity represented by an arrow with both direction and magnitude. Vector! That's me, as I'm committing crimes with both direction and magnitude. Oh yeah!
Well, we haven't seen this movie.
Hurrah, oh yes!
Okay, we're done with him. Wait, come on, we Despicable Me. This is number 1, right? Despicable Me, the first one. His name is Vector. Come on. As a math teacher, I'm like, yes, they found us, right? This is Disney, or is this not Disney? I don't want to say it isn't Disney. I can't remember who makes this one. Despicable Me. It's Disney, right? What else? Yeah. Sorry, I probably didn't get sued. Oh, you can't call it that. Direction and magnitude. What does magnitude mean? Yeah, what's magnitude? It's not magnets. What's magnitude? Yeah, what is it? Size. Right, so what is this? Ms. Orr showed this? Did you guys talk about vectors in physics? Yeah, we use it there a lot. So a size, direction and a size. So vectors have direction and magnitude. Oh yeah, yes. So here's kind of a, sort of how they work. The diagram shows a vector named fg. So here's how you write it, it's a vector fg. The initial point is where you start. So the order that you say fg matters. It says you start at f and you go towards d. There's your direction, right? And then its magnitude has to do with how far horizontally you're going and how far up you're going. So the vertical component for this one says go 5 right and up 3, and we give 2 values. Here's your horizontal, and here's your vertical. So a plus is to the right, a minus would be to the left, that's for horizontal. And vertical, a plus means up, and a negative means down. Okay, so component form of a vector. You have a turn point and your ending point. So let's see how it happens here. Looking at this guy, I want to name the vector. Now first of all, how do I name it? Where am I starting? B. And where am I ending? C. So vector BC. Now how would I write it in component form? Well, how many am I going horizontal? And it looks like I'm going right. So it will be positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then how many am I going down? 1, 2. Now down is a negative direction. So 9, negative 2 describes that vector in component form. They're not rocket science, you just have to kind of know the notation. If you're looking at this guy, and he's a little hard to see, he was on your paper there. Where am I starting from? Which one? Well, where's the arrow and where's the terminal point? Yeah? SR. SR. So you want to, because we're used to like reading English, but you have to say, oh wait, it's starting from S, my arrow's over here. So it's vector SR, there's your direction. Now magnitude. Let's think about the change in horizontal. I'm going 1, 2, 3, 4, 5, 6, 7, 8 of them. Well, which direction, right or left? Left, so is that positive or negative? Negative. And then how many am I going up or down? 0. So that vector would be negative 8, 0. Make sense? Yeah? Again, not so hard, but it's just a notation thing. Okay, good. So let's see here. So I can give you different ways that I can tell you to translate something. Here I am using a vector. So let's try this one. How does this work? A, so you plot your point. A is 0, 1, 2, 3. So I'm on the back here. And you can do it too. So A is 0, 3. B is 2, 4. 1, 2, 3, 4. There's my 3. And C is 1, 0. That's here. So I've got my triangle. There's my pre-image. So if I'm going to use this little vector here, I'm going to do the mapping rather than count boxes. And it's very similar to what we did before. So let's look at A prime. A prime is going to be 0, and then what does the 5 mean? Move it 5 to the right, so 0 plus 5. And 3, move it down 1. So 3 minus 1 is 2, so that's going to be A prime. 1, 2, 3, 4, 5, 1, 2, there's A prime. Okay, B, same thing. I'm going to go horizontal 5 units to the right, that makes that a 7. And then I go down 1. Okay, so that's 5, 6, 7, 1, 2, 3. That looks like B prime. And C prime is go right 5 from there, so that'll be 6, and then go down 1. Do run up, go down instead of up and down. Oopsie. That makes it be that's 5, 6, 7, 8. And then it's 6. Can you count and just go 1, 2, 3, 4, 5, and down 1? You can, look at the same way. But I do want to see what those points are. You can do that either way. So hopefully this matches what I thought it should. Yep, so it's showing the vectors. So A is vector here, B is this vector here, and C is that vector there. I'm showing the actual vectors, but if I'm just asking for the translation, I'm really focusing on this. I want to see the image from that pre-image. Okay, so not so hard. And really, that's kind of it. So I've got a couple of U-tries, just for you to see if you can do them. And that's basically all there is to the translation. How are we doing on these translations? Are we writing down the points? P prime 2, 9, P prime 5, 8, R prime 7, 5. You don't get that? If you have a question on where those are coming from, add 4 to the original x value, add 6 to the original y value. So here's my pre-image, and here's my image. This guy here, you're going to subtract 2 from x, subtract 5 from y. So my P prime is -4, -2. P prime, -1, -3. R prime, 1, -6. And then here's my pre-image, which matches obviously the same one there. But this time, my image is down below it. Questions on any of those things? Okay. The next thing is, can you kind of interpret what happened? What was the translation here? Did you get to do these, or are you still working on these guys? Still working on these guys? Go ahead and try those. I'm working on them. I put mine in both forms. So if you're writing in mapping form, xy maps to x minus 5y plus 3. Yeah? No? Maybe? And then vector form is you make your little vector component brackets, -5, 3, so this and this. Any questions how I got that? You started your original, your pre-image point. How did I get here? How many did I go left? 1, 2, 3, 4, 5 left. That's this guy left. And then I went up 3, and that's true for all the points. This one you should have gotten it maps to x plus 2y minus 5, or you write that as a vector component 2, -5. Questions on that? And that's translation, that's it. So not too hard.